Hi guys, welcome back to Tech Tutor. In today's video, we're going to have a look at the elbow plot. Now you might have come across the elbow plot while you were doing your analysis in RStudio or using R, right? But and you might have eyeballed this before also and wondered, am I getting that right value? Is there a better way we could calculate this precisely through mathematical means? And yes, there is a way. Okay, so let's have a look. So again, this is just as a reminder, this is what an elbow plot looks like. An elbow plot, it shows where the highest variance of data, right? So where is that? It tells us the point where that we use as a that has the highest variance, that has the highest impact in our data, right? And as we know, when we're doing principal component analysis, right, we reduce our data, which has many dimensions, say 100 dimensions, right, to something like 3 in this, right? So instead of using 100 dimensions, we do 3 dimensions. And over here, if you look, 3 dimensions is what we would choose as a dimensions, or DIMS if you used in your when you're doing your run PCA when you're calling the run PCA function, right? So yeah, so this would be our standard deviation on the y-axis, and the x-axis would be the PCs. Now, coming to what calculations we're going to do. The first calculation we're going to do is taking the larger value of the point where the principal components contribute only 5% and the principal components cumulatively contribute 90%. So the larger value of this, number 1. In our second calculation, you will see the point where the percent change in variation between the consecutive principal components is less than 0.1%. Okay? Now, coming to calculating the first metric, what we're going to do is we're going to determine the percent of variation associated with each principal component. So you could literally put this in your RStudio. Just replace this Seurat integrated, right, with your Seurat object. Okay, so these 2 spots, replace it with your Seurat object. And then this would help you calculate the percent of variation. It's going to be stored in the PCT variable. Then we're going to calculate the percentage associated with each of those each of those percent of variations, right? So that's in our CUM sum method. Okay, that's going to be stored in a CUMU method. In a CUMU variable. Then we're going to see we're going to calculate the maximum, which PC exhibits cumulative percent greater than 90%, right? And percent variation associated with the PC as less than 5%. Okay, and so we're going to see that, and once we do that, we're going to store that in CO1. So this is our first metric, guys. Any questions, please feel free to drop down in the comment section below. Now coming to the second metric, which identifies, we're going to identify where the principal components, where the percentage change in variation between the consecutive principal components is less than 0.1%. So what are we going to do first? We're going to see the difference between the variation of the principal component and the subsequent principal component, okay? So this is what we're doing. This is the calculation. I don't want to go in depth what we're going to do over here, but this is kind of, as you can see, this is going to take the PCT variable that we calculated, right? The PCT variable, right? And do some calculation that's going to calculate and it's going to store it in CO2. Okay, so this is going to be our last point where the change of variation is more than 0.1%. Now, so we got CO1 in this slide and CO2 in this. Okay, now what are we going to do with this? So we're going to find the minimum of these 2. Okay, so we're going to find the minimum of these 2, and that value is what's going to cover the majority of the variation in our data. And once you type PCS in your RStudio, that should give you your value. Right, and this is what kind of it looks like once you plot again. In this plot specifically, you can see it was something like 22, not 22, it was, not exactly sure, but yeah, so this point, this last orange point is where, and this blue point, basically, this blue point is where it started to get, where that exact, that elbow point, basically. Okay, but this calculation should work. And yeah, let me know if you have any questions. Feel free to drop them down in the comment section below. If you like this video, if this was helpful, please hit that like button, hit that subscribe button, and yeah, see you in your next video. Bye.